The first question asks us to solve this systems of equations by graphing the lines first and then looking at the point of intersection. I'm going to graph y equals 5x minus 1 in red. So if you notice, I plotted my first red point at -1 because the y-intercept is -1. Our slope comes from the b value next to x. It says 5, so that means I'm going to go up 5 from my y-intercept and then over 1. That allows me to plot all of my points up 5 over 1, up 5 over 1, and I can go down 5, left 1 as well, keeping that slope positive. Now I can connect coordinate points to make the line. The second equation is y equals -3x plus 7, so I've placed my y-intercept at 7, and then we're going to go down 3 over 1. Down 3 over 1. And what we're going to do is we're going to look for our graphs to intersect. And they do at this coordinate point right here, which is 1, 4. So our solution, our point of intersection should be 1, 4. Part B asks us to solve algebraically by setting the two equations equal. We can set the two equations equal because both equations equal y, so that must mean that 5x minus 1 is the same, it's equal to -3x plus 7. To solve this, we need all the x's on one side, so I'm going to add 3x to get rid of -3x. If I get all my x's to the left side of the equation, I'm going to get all my numbers to the right side, so I'm going to add 1, which I have a total of 8 x's on the left side. -1, +1 cancels. The 3x and the -3x cancels, leaving me with just 8. To get x by itself, this is multiplied by 8, so we're going to divide by 8 on both sides. And 8 divided by 8 equals 1, therefore x equals 1. So we're going to take 1 and sub it back in for x so we can solve for y. So if I just plug it into the top equation, y equals 5 times 1 minus 1. 5 times 1 is 5, minus 1 equals 4. Now that I have my x and my y value, I can write it as a coordinate where they intersect at 1, 4. And we've just proven algebraically that we get the same solution as we did when we graphed.